Well, good news for 80s and 90s generation geeks everywhere. HeroQuest is back on the market. And in order to celebrate, I wanted to share with you a HeroQuest dungeon randomizer that I've actually been working on for a while, since before the announcement of the return of the board game was made. But now that it's been announced, I thought it was a great time to share this with you. The goal of this code is to generate a randomized HeroQuest board so that you as Zargon do not have to make your own map or rely on the limited set of maps that they provide you in the quest book. You simply get to click a button here, run, and it will generate a random map for you. This is a work in progress. It is not complete. As we will see in a few minutes, there's still lots of things that I need to check. For example, this map that just got generated has 0 monsters. I did not know that that was possible. So let me make a note. Can generate monsterless dungeon. So I'm going to make that as a note. If you try this out and find issues with it or something that needs to be expanded or checked, let me know in the comments below. Like I said, this is a work in progress. But what I'd like to do in this video is just walk you through how this code works. The first thing we're going to do is embiggen the display so it's a little bit larger on the screen here so that we can actually see what's going on with our map. The next thing we're going to set, and this is stuff that you get to tailor as the user, is how many rooms should we use. So currently we are set to use about 50% of the rooms. So half the rooms are going to be used on average, half of them on average are not going to be used. So for example, here the central room of death where the bad guy's always waiting is not being used. There's no doors in or out. There's nothing inside the room. Same thing, the tile room here with the bloodstains does not have any doors, does not have any contents to it. Another thing you're going to choose is how many of the doors should be secret. So HeroQuest has normal doors that you can see, and you put in the closed door and then the open door when the heroes open it. And then you have secret doors that they have to check for with their... How did you find a secret door? I don't think there was a perception modifier. I don't know. I need to go back over the rules for this game before I order a copy. Then how many rooms should have monsters? That's percent monster here. Currently that's set to 25%, so about 25% of the rooms are going to have monsters. And then on average, how many monsters should be in a room? I said an average of 3. You could make this larger, right? You could make an average of, say, 10. That's obviously not going to work for all the rooms, but you could have a very monster-heavy dungeon. Yeah, I actually got an error here because we ended up overfilling the room there. So maybe we'll turn that back down to 3. Then the next thing we do is we're going to create a board. This is not the actual visual board here. That comes later. But what this does is creates a list of squares where we're keeping track of where everything is. So for example, once I populate a square with a goblin, I need to not have any more goblins there. Or better yet, once I populate a square with a door, I need to mark that that door is taking up this square to the left and this square to the right. I need to not place any goblins or furniture there, or else the heroes are really going to have a bad time. So here we're setting up the coordinates for this board. We have an X minimum on the left edge of -12, and X maximum on the right edge of 13. This is in X here is just to count the number of squares along the X axis. So if you wanted to trade this out for a different board, you could just change the geometry here. Same thing with Y. We have a Y min, a Y max, and then the number of Ys going north and south. Next, we're going to create a list of squares for the board. So this squares item here, this is going to be a list that records all of these locations on the board and what's in them. So we're going to loop over the grid. We're going to loop over the Y and the X. And then we're going to add to that this square. So the newest square has a size that's just shy of 1 by 1, right? We need a little bit of space in between there. And then we'll have our position vector here. That's going to be the center of that square. I have a color set here just to remind us of which room we are in, since each of these rooms has a different color to it. We'll say whether that square is visible. Currently, all of the actual squares are invisible. So if I turn this back to true, you can actually see these squares, these boxes pop up. Oh, they get covered by the board itself. That's right. So let's turn up their thickness a little bit. Okay, yeah, you can actually start to see them there. I guess I need to make them even thicker. Let's go and give them a thickness of 1 here. There we go. So here you can see the board without the image underneath. This is what it's actually creating there when you make these things visible. So you could simply go without the board image. If you want to turn this from visible equals false to visible equals true, you'd get this display here. Then you don't have all the, the board image and everything underneath that. But here we'll just turn that back to false just so we can see the actual HeroQuest board here. And so in order to do this, right, I've taken this 2-dimensional grid and I've collapsed it down to a 1-dimensional list. I didn't want to have to worry about multiple indices there. So what we're going to do in order to keep track of where the squares are in the list, I've defined this function here, square number, where you put in the x and y coordinates of the square you're at, and it returns to you that square's index in the list, just through this little counting formula here. So anytime you want to access it in the list, you just say square num of the coordinates. Now we have to keep track of which squares have been occupied. You can't have 2 things in the same square. Everything is fermions here, to use a physics analogy. And so we're just going to keep track of that in taken squares. Initially, no squares have been taken, therefore that list starts out as empty. Then we're going to come down to our icons. So this is just for visual. I have uploaded, I think I've got all of the icons loaded up here on Imgur. So I've got the stairs, I've got the tomb, I've got the altar, the rack, etc. Not all of these obviously been implemented yet. I'm not adding furniture yet. That comes later. We got the traps loaded up. We've got the door and the secret door. You can see I've already got those up here. So every time it's pulling in one of these images here, it's just pulling it from Imgur over here. I have all the monsters. Currently, we're just pulling in goblins. We'll add more later. And then what we're going to do, we need to create the rooms, right? So the HeroQuest board is great because it already has these rooms laid out for you. The rooms can take different roles and different relationships with each other throughout each different quest. You don't even have to use every room every time. But what we need to do is we need to keep track of which squares belong to which rooms, and which squares belong to those fun hallways that you walk around. You turn the corner and hope that nothing is lying down the hallway waiting for you. So these labels here are just to keep track of which quadrant they're in. That we're not actually doing anything with that. That's just to help. That was in writing the code, help me remember where I was. So basically for each room, I'm going over manually the dimensions of each room and then adding those squares to that room set, right? So there's nothing really inherent about each of these room shapes. They're kind of randomly drawn or arbitrarily drawn, especially this jerk right here with the corner taken out. We'll talk about him in a minute. And so basically we're taking each of those squares that's in that room. So for example, this upper left room here has these coordinates of going y from 8 to 5 and x from -11 to -7. And so basically we're taking each of those squares and we're adding those to this list temp. So that list temp is all the squares in this room, and then we add that list to the list of rooms. So rooms is a list of lists, each containing the squares in that room. So each room is represented by a list, and then those lists are collected in a list, right? Love lists of lists, great thing to do. And then this just repeats for all of the rooms. We go to the lower left quadrant, including these 2 tiny rooms over here. We come down here to the upper right quadrant. We're going to get all 5 of these rooms. We come down to the lower right quadrant. We're going to start with that stupid room with a corner cut out. So this is where we're looping over the coordinates of this room, except we have to check for that one corner. That doesn't make this whole thing difficult. We're only going to add squares if it's not that one corner. So 5, 4, or 5, -4 is this one square here that gets taken out of this room. Hate that room. Took me a while to figure out how exactly to code that in. And then just for later reference, whenever we need to check whether we're in that room, we're going to record what that room is here. Then we finish out the lower right quadrant. And then finally we get the central room of death. that's usually going to be where the boss is located. And so we just put that in here. It doesn't really belong to a quadrant. And then what we need to do for each of these rooms, we need to be able to tell what's going on in each of those rooms. How far does it go to the left? How far does it go to the right? What is the border of each room? Because obviously we need our doors to fall along a room's edge. We don't want our doors to fall in the center of the room. So for each room, we're going to record the room's xmin, xmax, ymin, ymax. That's just the room's boundaries in terms of the coordinates it already has. So we're just using the room's the coordinates already in the room. We're going to select the border to be all the squares along this room's border. So we loop over all the squares in that room, and if you are at the xmin, xmax, ymin, or ymax for that room, then you're along the border. That square gets added to that room's border. And finally, we'll record that room's number just so we can find it inside the list of lists. Finally, any squares that are left must be in the hallway, right? So we've taken out all of the squares that are in the rooms. Everything else must be this fun hallway that wraps around. And so we just create a list called hallway. We loop over the squares, then we loop over the rooms, right? So we want to be able to tell, is the square in the room? That's what we're asking here. If the square is in the room, then it's not in the hallway. So that means in hallway equals false. If you still survived by the end of that, if you were never taken out because you're in one of the rooms and you must be in the hallway, so we're going to append that square to the hallway there. So every square is either in a room or a hallway. Then here's where we overlay the board. So all of that is just taking care of all of this geometry math. This is the first time we'll actually add an image. So here we are creating a box. So if you look carefully, you can see this thing has a little bit of thickness to it along this edge. So what we're doing here is we are adding a box. So this big rectangle here is a box. It's in the center of the screen, offset just a little bit so that it aligns with the grid of boxes that we've set up. Its size is going to take up the entire grid that we're making, and then we overlay that image of the game board using the texture function in GlowScript. It allows you to take an image from anywhere accessible on the internet and just overlay it here. So that's what we're doing. We're overlaying the HeroQuest board on the edge here. Our next goal is to start adding stuff to the rooms. So in order to do this, we need to be able to choose random locations for these things to go. So the first one we're going to define is a uniform random distribution. I believe GlowScript now allows you to import some random functions, so we probably don't need this custom definition anymore, but I like having it just in case. So what we're going to do, this is going to have a random uniform probability distribution of picking a number between x1 and x2. This is going to be useful, for example, when you want to pick a coordinate in a room, you say random xmin to xmax and random ymin to ymax to get a random location inside the room. Here is how we're going to randomly choose a room. We are picking uniform between 0 and the length of room. So we're going to go anywhere from 0 up to the number of rooms, not including the endpoint there, because you can't choose from the end of a list. Let's see, here we are picking a random item from a list. So in this function, you're giving a list. Maybe it's a list of rooms. Maybe it's a list of squares in the room. Maybe it's a list of possible monsters that you can choose. And so then here we're going to say, okay, you're going to choose a random item from there. And so what we're doing here is calling the nth item from that list. We're picking a random number n, and then we're drawing a random item n from the list. This is a very important part. We are keeping track of which rooms we are using, right? We don't want to add stuff to rooms that we have not used yet. We'll come to where we use that in a little bit. Here's where we are defining how we're going to place a door. So in this function, we are placing a room inside of a door. The room comes in with a texture. So text is going to equal whether it's a door or secret door. And we're going to choose that elsewhere. We'll come to that in a minute. First, we need to figure out where on earth can we place these doors, right? Because say, for example, we're in the green room. I can place a door anywhere along the wall. Let's suppose I'm in this teal room. I can place a door anywhere along the wall except the one the goblin's in. Or if I'm in this room, I can place a door anywhere along the wall except this square here. And so what we do, we look for the number of squares that are in the room's border. This is why we defined room.border earlier, is so that we could just loop over all of those squares, including this jerk. And so then we look for whether that S is taken, right? Has something been placed in that door, something placed in that square already. So we're checking for whether something has been placed in that square. If it's not, if it hasn't been taken yet, then we say that that spot is available. You can choose that spot for your door. So then we say, okay, spot equals pick an item from the spots available. So we take from this list, right? These squares, they may or may not be a contiguous list, right? There might be stuff in the middle. So we might have an available square and then a not an available square and then an available square and then not an available square. This is just picking out from all the available squares. We set what the X and Y are going to be for that door. Here we create the door. So this is going to be a box. It's going to have a size that is longer than it is tall, right? Because we need these doors to be a sliver of a rectangle that can fit between these two squares and still leave those squares mostly visible. The texture is going to be either the open door or the closed door, depending on which one we're passing to this function. Here we are trying to figure out whether the door is on the left edge, the right edge, the top edge, or the bottom edge. So we're checking for whether the X is on the minimum, the maximum, etc. That just determines how the door gets placed, right? So if you're on the left edge, you want to scooch over to the left a little bit. Whereas if you're on the right edge, you want to scooch over to the right a little bit. That way you're lying in between the two squares here. You don't want the door in the middle of the square. Similarly, we might need to rotate this image, right? So initially it's set to be a vertical image. Otherwise, we need to rotate it to be a horizontal image. And so that's what we're doing here with looking at how we're going to rotate these things. You notice you have to rotate it if you're on the left or right edge. You don't have to rotate it if you're on the top or bottom edge because it defaults to that vertical alignment there. I have an else here in case we do end up not on an edge. That shouldn't be happening. But just in case it does, we need to have something for it to do, so it's going to place it there. I haven't seen that happen, so fingers crossed that we never get there. In fact, maybe I should add a print. I don't know how I got here, ... So if you get that error, let me know. All right, so then we need to mark that square that we used as being taken. We also need to mark the adjacent square as being taken because, for example, when I populate this square here with a door, when I place this door here, I need to mark the square to the left and the square to the right as being taken because I don't want, while I'm in this room, to pick a door here, and while I'm in this room to pick another door here, or to pick a goblin here, or to pick a door here, because that's going to crowd out the board. You don't want a goblin sitting here right on top of the door waiting for the hero when they open the door. So we're just taking up both the neighboring squares. So if it's a vertical door like this, it'll pick these two squares. If it's a horizontal door like this, it'll pick these two squares. And of course, we need to mark that room as being used. Now we can put other stuff in that room. We want to make sure that we are using the rooms that we populate there. Yeah. Let's see. So what we're doing whenever we want to place a door, we either place a secret door or place a door. And basically this just determines, do we use the secret door texture or the door texture? They're both calling that place D function that we just used above. All right, now let's talk about placing monsters. So we want to place a monster at a random location in a room. So again, we're going to check for the spots available. That goes the same way it did before. We're checking for whether we've already placed a door or a monster there. And then we're going to say, okay, here is where the monster is going to go. And we're going to pick a monster here. Currently, only goblins are available. So we'll add, that'll probably be the next thing I add in, will be picking other types of monsters. So the first thing we're going to do in order to place things, we're going to place the stairs in a room. The stairs are where the heroes enter and exit the dungeon, except for that one quest I remember where you were prisoners and you had to break out and then you had to find the stairs. That was different. But you have to have stairs. You have to have an entrance and an exit to the dungeon. And so we are making that a box with the texture stairs. We are going to place that in a random room, right? So I need to choose which room that's going to go into, mark that room as used, right? We obviously want to make sure we get a door out of that room later. And then what we're going to do, we're going to place the stairs in a random location within the room. In this case, it ended up in the center. It could also end up in a corner somewhere. If I run the code again, here it ends up in the center. It's just going to pick a random 2x2 space inside of the room. We are going to make sure that we end up in a spot where it's not overlapping. And so we're taking care of that in here by looking between xmin and xmax -1 and ymin and ymax -1. The -1 there makes sure we don't end up overlapping with another room. Here we are marking those as taken squares, and then we need to make sure we have a way out of this room. So we are placing a door inside the room with the stairs. Benevolent Game Master. So let's see. Next, we're going to select which rooms we're going to use. So here we're generating a random number, and if that random number is less than the percentage of the rooms to use, then we use that room. That's the way we'll guarantee we're using approximately the percentage that we said. It's obviously not a large sample size, so plus or minus whatever your results end up being there. The next thing we're going to do is make sure there is at least one door in every room that is to be used. So what we're going to do, we're going to loop over all the rooms to be used, and we're going to say we're going to pick a random number to determine whether we're going to place a regular door or place a secret door. There's definitely going to be a door either way. This is just going to determine whether we have a regular door or a secret door, and that's based on this percent secret door. So you could choose percent secret doors to be 100 and make all the doors secret doors. I'm sure your players would love you for that. The one thing that I need to check in here is whether the room is necessarily accessible. So for example, here you come out of the stairs here, and I've got a door there that really should not be there. I have a little mistake there, it looks like, so I need to check on how that's checking. But you come out of here, you can go through this door to get to this room, you go out this door, and once you're in the hallway, you can pretty much get anywhere, it looks like. So like this door is hidden behind this room, is hidden behind this room, is hidden behind this secret door, but you can still get there, right? So there's a way to get to every room that is on the list of rooms to be used, but that isn't guaranteed. So for example, in this dungeon that I just generated, you come out the stairs here, you have this nice double door leading to a dead end. You come into this room that has this door leading to, again, a dead end. There's this entire rest of the dungeon that has a door accessible here and a door accessible here, but you can't get out of this quad of doors. So right now we are not checking for whether every room that is being used is accessible from the stairs, right? I've got another example over here of one I created earlier where you can't get out of this cluster of rooms. You can navigate through here to this room of death, into this room of death, and then up to this final goblin surprise, but you can't get to anything else because you can't get out into the hallway. There is a spell in the game that lets you pass through a wall. It's not the most advisable spell in the world because you can end up being stuck in stone forever, but you could in principle pass through the wall to get to the hallway here and then pick your way along here. But what happens if your wizard dies in this room, or you're playing with 3 players and they didn't pick that spell? That's not the best thing in the world to have happen. And so I need to put in a check here to make sure that all rooms are accessible. Finally, here's where we place monsters in the room. So we are choosing whether there are going to be any monsters in the room. So this is if random less than percent monsters. And not if it's in the room with stairs. So general best practice, don't put monsters in the room with the stairs. If you want to be a mean Zargon, you can remove that. Otherwise, we're going to choose the number of monsters here. I've got this set to go between 1 and 2 times the average number of monsters, so that the average is about in the middle there. And then we're going to go about placing monsters using the function that we defined above. So I would love to get some feedback on this. If you get Hero Quest for a holiday gift this year, would love to hear how this map works out for you. I think my next goal is going to be to add a better randomization of the monsters here. Would love to hear some feedback from you in the comments below about how this works or how it does not work for you. Thank you so much for watching. I will see you next time. Bye-bye. The goal of this code, which is available at a link in the description below, is to randomly generate a Hero Quest. Heroes Quest? Which one was which? Hero Quest was the board game. Heroes Quest was the video game that got renamed Quest for Glory.